Welcome to chapter 1.1. We are solving linear equations. In today's lesson, we have two goals. We have the first goal, which is I can translate verbal expressions into algebraic expressions and equations and vice versa. This is something that you should have done in Algebra 1, but we are just bringing it back so that it comes back to memory in Algebra 2. The second goal that I have for us in this lesson is I can solve equations using the properties of equality. So we're going to first start off with being able to translate. Be able to go from words and write an equation, or go from equation and write it in words, or an expression. So first off, let's start with a question. What is the difference between an expression and an equation? Because both of these appear in mathematics. Both an expression appears and an equation appears. So the main difference between the two is this symbol right here. That is an equal to symbol. Main difference is an expression does not have an equals to. It's not really solving for something. It's expressing something. It's not really a solution. An equation is made up of two expressions set equal to each other. An equation is two expressions set equal to each other. So an expression typically does not have an equals to sign. An equation typically has an equals to sign. So that's the main difference between an expression and an equation. So let's look at a few examples of translating. We're going to start with writing out an expression and writing out equations. I do have a handout, and in fact, that handout is posted on the website if you want to get access to that. If you are in person, I will hand it to you at the end of this lesson. So example 1, write an algebraic expression or equation to represent each of the following. So we're taking all these words, and we want to write an equation for this. So part A, 5 times the sum of a number cubed and 7. Well, we know what the word times means. We know that that's multiplication. We know that sum means addition. We know that cubed is an exponent of 3. Okay, so something to the power of 3. It's an exponent. So 5 times the sum, 5 times the addition of something. So we put 5 on the outside. We're going to put parentheses because it's times an addition of something. The sum of a number, a lot of times they will give you what variable they want to use. But because it says a number, we get to choose a variable. For this case, I'm just going to choose x because x is the most common variable. So the sum of a number cubed. So a number cubed, so x cubed, and 7. And that is the answer to the first one. We have 5 times the addition, the sum, of a number cubed and 7. That's the answer to part A. That is an expression, not an equation. It's not really asking you to solve for anything. It's just expressing itself. Part B. A number decreased by 26 results in the quotient of 2 and the product of 8 and the same number. Okay, well, let's pick out all the important pieces. We have decreased. A number decreased. We have results. We have quotient. We have product. And I think that's all of the ones I see currently in here. Decreased. What does decreased mean? Well, decreased means to take away, to subtract. So this would be a subtraction. Result. And result means that we're setting two things next to each other. They're equal. Quotient is division. And product is multiplication. Just more words meaning the same things. Remember, we had times, we have multiply, we have product. We're just slowly building a sheet of words that mean certain things. So, we have a number is decreased by 26. I'm going to choose a different number. Let's say we use y. We use a variable. Okay? So we're going to choose a number, which we're going to call y. And we're going to decrease it by this other number. So y goes first, subtracted by 26. So y minus 26, a number decreased by 26. Results, or is equal to, right? So this is going to be our equal to sign. In the quotient, so we're going to have a division of 2 and the product of 8 and the same number. So product means multiplication. We're multiplying 8 and that same number that we had chosen before. So this would be 8 times y. So let me just highlight. So we have, the highlight is not going to go through very clear. Let's see if we can get a different. Nope, that's not going to work. So that is the result. A number minus by 26 decreased by is equal results in a division, a quotient of 2 and the product of 8 and y, or that same number. Letter C. The ratio of 2 and the difference of 42 and a number. Okay. Ratio. Ratio is another word for fraction or division. So we are going to have a division here. Difference means subtract. So we have a division, we have a subtraction. So ratio, let's do a division. The ratio of 2, so 2, and the difference means subtraction of this other thing. Difference of 42 and a number. Let's call this number z. So we have an expression. We had an expression, we had an equation, we now have an expression. The next one's probably going to be another equation, most likely. So we have 2 divided by 42 minus z. Part D. Twice some number raised to the 12th power is the same as some different number less than negative 99. Okay, well, let's pick out the key things. Twice some number. If we're doing twice something, that's 2 times. Okay, that's 2 times. Raised to the 12th power. That's an exponent. So 12th power is an exponent of 12. We're going to just put x. Is the same as is saying equals some different number. So this is a different number. Less than, this is a one you need to be careful on. Less than, so we're taking this number away from negative 99. Okay? So, here's what we have. Twice some number. Let's go twice, let's say a. Twice a. Okay? It's some number. It's a variable. It's some number that we have. Raised to the 12th power. Twice some number raised to the 12th power. What this is saying, here's our question. Let me back up just a little bit. Twice some number raised to the 12th power. Is that saying that this whole thing is raised to the 12th power, or just that some number is raised to the 12th power? That's what we had to figure out. Twice some number raised to the 12th power. I'm going to say that this is going to end up to be that it's the some number that's raised to that 12th power. Okay, there may be some debate about that, and we can talk about that, how to tell the difference. And it has to do with a little bit of the wording. So twice some number that is raised to the 12th power is the same, so is the same equals, to some different number less than negative 99. So we are going to go, because this is less than, we actually have to kind of reverse it. We're taking this part away from the other part. So negative 99 goes up front, and then the other number goes in the back. So we're going to do B. Okay, so we have twice a number that's raised to the 12th power is the same as negative 99 minus by this other number, or this other number taken away from 99. Okay, so if we have any questions, make sure that we ask them at the end. Example 2. We're just going to go backwards now. We did the first part where we wrote it as an equation. Now we're going to take the equation and write it as verbal words. Okay, so we have 2b to the 4th minus by 3a. Let's actually write that down. We have some multiplications in there. We have a subtraction in there. We have a 4th power. So let's do it this way. We have, let's go twice some number raised, or to the power of 4. Let's go twice some number. I'm going to do raised to the power of 4. And I'm going to actually just write out 4. Subtracted by the product of 3 and a different number. By the way, this is not the only way to write it. You could choose different words. You could say, instead of product, you could say the multiplication of this other number. You could say, instead of saying subtracted, you could say the difference. Or you can say that 3a, the product of 3a, less than this other thing. Of course, you use the words to be able to describe it as well. But I'm just trying to say that you can use different words to mean the same thing. Okay, this is not the only way of saying this. Okay, this one, part B. We have 1 over 2. That's half. Half of x, or half of a number, plus 3. So we can say half a number plus 3 gives us negative 7 times, it's a difference, right? Times the difference of the same number and 5. And that's how we would say that one. Of course, it may be another way of saying it as well. You could choose different words that mean the same thing. So it's half a number plus 3, or you could say the sum of half a number and 3 is negative 7 times the difference of these two other numbers. We could also, where was I going with that? We could also word it in a different way if we really wanted to as well. But that's the main difference. We're just going back. We're just going one or the other. We're doing the writing it as an equation other than writing it as an expression. So that's the first two examples. In fact, finishing up those first two examples, we have now, hopefully, reached our goal of I can translate verbal expressions into algebraic expressions and equations and vice versa. So that is part A. just being able to translate, can you go from the words to writing it out nice, or can you go from writing it out nice to writing it in the long form, which is words? It is so nice to have these symbols. These symbols make it so much more concise. Rather than having a whole 2 lines of words, we can just write it as one short little simple thing, something short, sweet, to the point. So here's another question whenever we are getting into the second part of this. What is a solution? Well, we talked about an expression. We talked about an equation. An equation is whenever you put 2 expressions next to each other and set them equal. The solution is whenever we say or find whenever those 2 expressions actually are equal. Make sense? It's whenever those 2 expressions are actually equal. What makes them true? What makes them true for each other? So let's talk about a few properties of equality. This is going to be very theoretical for a moment, and then I'm going to give you an example. Okay? So here's what we have. For any real number A, any real number that we have, let's call it A. It's a variable. If A is the same as A, that is reflexive. That is our reflexive property. In fact, we talked about this some in geometry last year. Reflexive property is whenever they are equal to itself. Symmetry, or the symmetric property of equality. For all real numbers A and B, if A equals B, then B equals A. Does not matter if you put B in front or A in front. That's the symmetric property. Transitive property. For all real numbers A, B, and C, these are 3 different numbers. They could be the same number. If A equals B and B equals C, then A equals C. We can take out the middle step. Okay? With this one, we just want you to be able to recognize these things. Substitution. If something, then A may be replaced by B, and B may be replaced by A. If A equals B, then they can replace each other. So let me give you a few examples of this. If you see something along the lines of, let's say 5x plus 7 equals to 5x plus 7. It's equal to itself. That's a reflexive property. If you see 2 things equal to itself, reflexive. Okay. If you see symmetric, here's symmetry. Let's say we have x equals to 3 times x plus 7. Then if you see 3 times x plus 7 equals x, just scroll up just a little bit, then that is symmetry. Right? They are just in opposite positions. Right? It's symmetric. Transitive property. The transitive property could be something along this lines. If we have 3x plus y equals to 2, and if we have 2 equals to 5z, then in other words, this would be 3x plus y equals to 5z. Right? Because this equals 2 equals that one, so they must be equal. A equals B, B equals C, so A equals C. You can cut out the middleman. Substitution. Basically, you guys have seen this a lot. Let me show you what this one is. Let's say we have 2x plus 5y equals to 3. And let's say that we know that y is equal to 2. Well, if we know that those things are true, then we can now say that 2x plus 10 equals to 3. Right? Because y is 2, replace, so 5 times 2 is 10. 2x plus 10 equals 3. You can substitute. It can take the place of the other number. Good? Okay. So that is our properties. So now let's look at an example. Let's figure out what property is being used. Is it reflexive, symmetric, transitive, or substitution? Part A, if 8x plus 2 equals to 7 times y plus 1, then 7 times y plus 1 equals to 8x plus 2. That, they are just reversed. So that is reflexive property. Just be able to, not reflexive, symmetric. Woo. Make sure that we know what each of them are saying. Symmetric. Second one. Well, 2x plus y, 7y, equals 2x plus 7y. That's the same, so that would be reflexive. Just be able to recognize which one we are actually using. If we know that 6x plus y equals to 3, and y is equal to 5, then 6x plus 5 equals 3. Substitution, right? We put it in place of the y value. So this is substitution. You kind of got an extra example with the explanation up there. If we know that 4 times x minus 7 equals to 2x, and 5y plus 12 equals to 2x, then 4 times x minus 7 equals 5y plus 12. Well, this one happens to be kind of a mix of symmetry with our transitive property. Why do I say it's a mix of the two? Well, 5y plus 12 equals to 2. Isn't that the same as 2x equals to 5y plus 12? Okay, well, if that's the same thing as 2x equals to 5y plus 12, then now we know, because they both have the 2x in common, that we can just put the transitive property to work and cut out the middleman. So we end up with just the outers. So that's why I kind of say it's a mixture of the two. The textbook actually is only looking for you to be able to recognize that it's the transitive property, but I want you guys to be able to say that it actually is using both. Okay, so we are going to say symmetry or symmetric slash transitive, because we are using both of them for this one. Okay, so that is example 3. Here's a few more properties of equality. We have the addition and subtraction property of equality and the multiplication and division property of equality. For the addition subtraction, for all real numbers a, b, c, if we know that a equals b, then we know that a plus c equals to b plus c. Right? We can add a new number as long as we add it to both sides. Right? A equals b, we can add on a constant to both sides. Or we can subtract a constant on both sides. Either or. For example, let's say we have x plus 6 equals to 7. Well, how do we get x alone? We're going to use the subtraction property. So we are going to subtract 6 on both sides. That's using this symbol, right? These symbols right here. So that is our subtraction property at work. We could also use the addition property. Multiplication, division, you guys, it's not really any different. Main thing that's different is that c cannot equal 0. I'll explain that in a moment. If a equals b, then we know that a times c, I'm actually going to move this down just a little bit, a times c equals to b times c. You can multiply on both sides as long as you multiply by the same constant. You can also divide. So a divided by c equals to b divided by c. C cannot equal 0 because if we have a division by 0, we have an issue. That is undefined. That's not possible for us to be able to do. So that is why we restrict c to not be able to be 0. For example, if we have, let's say, 3x equals to 9. If we want to solve for x, we would do division. Right? We can divide on both sides. And we would end up with the same result. So that's our properties of addition, subtraction, multiplication, division. Let's look at example 4. Okay, so looking at example 4, we have solve each equation, check your solution. Okay, so we have x plus 7.02 equals to 8. Which property of equality are we going to end up using? Well, we have a plus 7.02, so we end up doing the opposite, so we end up subtracting that value. So minus by 7.02, minus by 7.02, we can end up with x equals, let's put a few zeros behind. We're going to have to borrow, so this become a 7. This would be a 9, this would be a 10. So we end up with 8, we end up with a 9, and we end up with a 0 in front. So x is 0.98. We want to check our solution. So let's go plug it back into the original. We're going to put it check. So 0.98 plus 7.02 is indeed 8, so that works. So that is part A of example 4. Part B of example 4. We have negative 7 over 8a equals to 14. Don't know why there's a point there, but we will pretend like it doesn't need to be there. So we have negative 7 over 8a equals 14. Anytime you have a fraction, let's treat it as a multiplication. Okay, as if this is a multiplication. If we want to get rid of this negative 7 over 8, we're going to end up dividing by negative 7 over 8. Divide by the same value. However, division of a fraction is actually multiplication of the reciprocal. So here's what we're going to do. This is a division by 8, so let's multiply by 8. This is a multiplication of 7 to that a, so let's divide by 7. Okay, we'll deal with that negative in a moment. Okay, so let's do the same thing to this side. Remember, whatever you do to one side, you have to do it to the other. We multiply by 8, divide by 7. Let those go away. Multiply by 8, divide by 7. So this would be a negative a equals to 14 times 8 over 7. But remember that we can simplify. What's 14 divided by 7? That gives us 2. So this would be a 2 on top. That would be a 1 on bottom. 2 times 8 is 16. So negative a equals 16. So if negative a is 16, then what is positive a? Negative 16. So let's check our work. Okay, so to check our work, we have negative 7 over 8 times negative 16 equals 214. Let's make sure that this works. 16 and 8 have 8 in common, right? They have 8 in common, so we get rid of. This gives us a 2 on top. Negative 7 times negative 2 is indeed positive 14. So that all checked out. Remember to check your work. Make sure that we end up with the same results. Okay, that's part B. One last property of equality. One last property of equality before we end this lesson. And this is the distributive property. You guys have all seen the distributive property before. At least I hope you have. Basically, if you have any real number, a times b plus c, then this is going to be the same thing as ab plus bc. AB plus ac. Basically, what happens is you can take this a and put it with both of those numbers. You're distributing it evenly among those two values. So, for example, let's say that we have 2 times 3 plus x equals to 5. This would be the same thing as saying 6 plus 2x equals 5. And we are going to stop there. We will pick up on this lesson tomorrow. We have completed part A of this, which is I can translate verbal expressions into algebraic expressions and equations and vice versa. And we started with the solving equations using properties of equality.